This question asks us to use the principle of superposition to find the output voltage. That's V out, the voltage across the 50 ohm resistor. So there are two parts to this circuit. There are two independent sources and one dependent source. Now, this dependent source, the current source, we don't touch, we don't remove that. What we do in superposition is we remove, eliminate, or zero all but one of our independent sources. So we remove them all and then retain one by one our sources and then calculate the value of V out. So in this case, we'd first remove the 15 volt voltage source, turn it into a short circuit. So we essentially make the voltage 0, and we calculate the value of V out. Let's call that V out prime, and to do that we'll need the value of V in, and we'll call that V in prime because that will be used by our dependent source here, that's 0.1 V in. And then we'll do the same for the other source. So we'll replace the second source by a closed circuit, and we'll calculate the value for V out, and we'll call that V out double prime, and V in, and we'll call that V in double prime. And our final answer, V out, will be the sum of these two. So it'll be equal to V out prime plus V out double prime. So let's start by removing the first voltage source. Now, it looks like we now have the 100 and 500 ohm resistors in parallel. So our parallel equivalent of the 100 and 500 ohms, 250 over 3 ohms. So now we know the parallel resistance. We can find V in dash using a potential divider. So it's the input voltage 20 multiplied by 250 over 3 divided by the sum of 250 over 3. And that gives you 100 divided by 17 volts. Now we know V in dash, we can find the current in the dependent current source, which is 0.1 times V in dash. So 0.1 times 100 over 17. So that's 10 over 17 amps. And that's going to pass through the parallel equivalent of the 5 and the 50 ohms. So to find V out dash, it's just the product of current times resistance. So it's 10 over 17 multiplied by 5 in parallel with 50. So that's 10 over 17 multiplied by 50 over 11, and that gives you. Now, if we were to eliminate the second voltage source, again by replacing it with a short circuit, we now have the 500 and 200 ohm resistance, and that gives you 500 divided by 187 volts. So that's V out prime. We found that by short-circuiting the first source and retaining the second. Now, if we were to eliminate the second voltage source, again by replacing it with a short circuit, we now have the 500 and 200 ohm resistances in parallel. So our RP is now 200 and 500, and that gives you 1000 over 7. And again, to find V in, or V in prime, or double prime in this case, it'll be, again, the voltage divider rule. So we have our input voltage this time is 15, and we multiply that by 1000 over 7 divided by the sum of 1000 over 7 plus 100. And that gives us 150 over 17 volts. So now we know V in, we can find the current in this dependent source, and that current is 0.1 times V in, or times V in dash dash, should we say. So that's 150 over 17 times 0.1, so that's 15 divided by 17 amps. Then to find V out, it would be that current multiplied by the parallel equivalent of 5 and 50. So that's 15 over 17 multiplied by 50 over 11. So 50 over 11 is the parallel equivalent of these two. And that will give you 750 divided by 187 volts. So now we've found V out double prime, we can go back and find V out as the sum of V out prime and V out double prime. So it's the two voltages that we found. So our first voltage was 500 divided by 187. And we add to that 750 divided by 187. And that gives us 6.7 volts. So that's our final answer. That's how you would find V out using superposition. That's by eliminating all but one of the independent sources, replacing it with a zero, so a short circuit for a voltage source, and an open circuit for a current source, but retaining or keeping the dependent source.